EES, which is pronounced ease, is an acronym for Engineering Equation Solver. The next few videos will describe one of the most important features of ease, which is its built-in property database. Historically, thermodynamic and transport property data for fluids were provided in tabular or graphical forms. You don't have to solve many engineering problems using property tables before you get pretty tired of the time-consuming interpolations that are involved. And also, it's really difficult to carry out any type of parametric study or optimization with this kind of information. So ease provides high accuracy thermodynamic and transport property data for many different substances that can be accessed very conveniently and therefore used in all types of parametric studies and optimizations. And these data are accessed with the built-in property functions that are described in Chapter 4 of Mastering Ease. However, before you use any of these property functions, it's absolutely critical that you specify the unit system that ease will use for the thermodynamic and transport property functions. The unit system controls both the units of the input parameters that ease expects for variables that are provided to these functions, as well as the units of the properties that are returned by the functions. The unit system can be specified in two ways. One way is to select Unit System from the Options menu in order to display the Unit System tab of the Preferences dialog here. You can notice first that the unit system can be specified using either SI or English units. It can't be specified in any kind of combination of these two though. In SI units, the units of temperature can be either Celsius or Kelvin, the energy can be joules or kilojoules, and pressure can be specified in pascals, kilopascals, bar, or megapascals. Values of specific properties can be specified on either a mass or a molar basis. So some examples might be specific volume or specific heat capacity, specific enthalpy. So recall that a mole of a substance is defined as the amount of mass that is equal to the molar mass of the substance, or the molecular weight of the substance. Therefore, the mass units actually need to be specified when you're specifying a mole. So for example, if the mass unit is chosen to be kilograms, which is what it has to be in SI units, then the corresponding molar unit must be kilogram moles, or sometimes this is referred to as k-moles. The molar mass of helium is 4, and therefore a k-mole of helium has a mass of 4 kilograms. If we switch to English units, you can see that the mass basis is pound, and therefore the molar basis is a pound mole. And again, a pound mole of helium would have a mass of 4 pounds. You can select either Fahrenheit or Rankine for temperature, and PSI or atmosphere for pressure. In English units, energy units can't be changed. They will always be BTU, the British thermal unit. An alternative and probably better way to specify the unit system is to use the $unit system directive. This directive has the following format for SI units, so you can see right here, and you notice that each of the selections in the $unit system directive is exactly equal to the selections that you would have otherwise made in the unit system dialog. So as an example, the following line placed in the equations window will set the ease unit system to standard SI units, temperature in Kelvin, pressure in Pascal, and energy in joules. Specific properties will be expressed on a mass basis, and also trigonometric functions will expect and return angles in radians. So this clearly shows the user what the unit system is for the ease code that follows. The selections can be made in any order. The $unit system directive in English units has the following format, which follows closely to the ones in SI. Again, every selection you could have made in the dialog window, you can make right here. Mixed SI English unit specifications are not allowed. So for example, you can't set the pressure in PSI and the temperature in Celsius. Every specification in the $unit system directive is separated with a space. It's not actually necessary to enter all of the unit selections if you don't want to, but if you don't, then the unspecified ones will default to whatever has been set in the preferences dialog. It's generally really good practice to make sure that you make a complete selection of all the units right here in the $unit system directive. Normally you place the $unit system directive right at the top of an equation window, so that, as I said before, it's obvious to the user what the unit system settings are. If a $unit system directive is used, it's going to override any settings that would otherwise have been made in the unit system dialog. Again, normally the dollar unit system directive is placed right at the top of the equations window and then applies to the entire ease code. However, functions, procedures, and subprograms can actually each have their own separate and different unit settings, and you can do that by placing a dollar unit system directive within those program units in the equation window. If you don't do that, then the unit system settings for the functions, procedure, and subprograms will be the same as those for the calling program unit, and that's the typical situation. The unit system settings are displayed in the center of the status bar at the bottom of the equations window as well. You can see that here. If you click on the unit section in the status bar, you'll get the unit system dialog window. Again, the choice of a unit system will control both the expected units of the parameters that are provided to the property functions as well as the units that the property function return. So if the units for temperature are selected to be Kelvin, then any temperature value that you ever provide to an ease property function is going to be assumed to be in Kelvin, regardless of what the units may have been for the actual variable that you provide. If the units of the input parameter to the function don't match the specified unit system, then ease will display a unit warning message, but it's going to always use the units that are set by the unit system specification. This is one of a series of tutorials meant to describe the operation of the ease software. If you want to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from the fchart website.